Welcome! This activity is called Magic Science Show and is aimed at 9 to 11-year-olds. It will take 60 minutes or more to do. In this activity, you'll be getting children to try out a range of different magical tricks that involve science to make them work, before getting them to put on their very own magic show. They'll be using air resistance, water resistance and friction, and the force of gravity, working scientifically to design and make products and explore their effects. It's important with this activity to create and stick to a suitable risk assessment and to make sure that appropriate eye protection is worn for certain parts. It's especially important to ensure children handle the hairdryer with care, and they should be aware of potential sharp points when handling metal coat hangers. Once you've done all that, you're ready to start the activity. You should start by explaining to the children that sometimes there's not a lot of difference between magic and science. So you're going to get them to try out a range of different science activities that can be incorporated into a magic show they can perform. You should now hand out the photocopied student guide instruction sheets and pick some, or even all, of the tricks for the children to practice and then perform. Alternatively, you can make the task harder by providing materials without the instructions. See if the pupils can figure out the trick before you reveal it to them. You could also ask them to research their own science magic tricks and perform these later, maybe even inviting an audience to watch the magic show. Now I am going to show you how to do the tricks yourself so that you understand them before giving them to the children to try. Trick 1. Flipping a glass of water upside down without making it spill. For this magic trick, you'll need the following items: pint glass or plastic beaker, sheets of card of different thicknesses. Make sure the square of card is 2.5 centimeters larger than the glass or beaker on all sides. Fill the glass or plastic beaker with water so that it is completely full to the brim. Place the card over the mouth of the glass. Make sure the glass is in the center. Hold the glass over the washing up bowl just in case. Place one hand on top of the card and quickly turn the glass upside down, holding the card in place. Slowly remove your hand from the card. So, how does this work? First, the pressure of the air is higher outside the glass than inside. This pushes the card upwards and holds it in place. The surface tension of the water also helps to hold the card in place. Trick 2. Make a ping pong ball levitate. For this trick, you'll need the following items: ping pong balls, various other balls, hair dryer, and safety goggles. Turn the hair dryer onto the highest setting and point it upwards. You might want to suggest that the young people try different temperature settings to see which works best. Gently put the ping pong ball in the middle of the flow of the air from the dryer. It must be centered for the best effect. So how does this work? The ball is very lightweight, so the force of the hairdryer is strong enough to lift it. Because the ball has a curved surface, the force of the air all around it is balanced. This keeps it from moving side to side. It's the same thing that happens with an airplane wing. The rushing air causes lift, which pulls the plane up. Trick 3. Balance a penny on the end of a metal coat hanger. The following items are needed for this trick: metal coat hangers with sharp edges filed away and already bent into shape, various coins, and safety goggles. Prepare a hanger beforehand so that it makes a square. You may also need to flatten the end of the hook where the penny will rest with a file. Place the bend of the hanger on your index finger and let it hang so that the hook is hanging down freely. Balance a penny on the flattened end of the hook. Slowly swing the hanger back and forth. The penny should stay in place. Try and do a full loop-the-loop. Remove the coin at the end to prove to your audience that the coin was not glued on. Let's look at the science behind this magic. As the coat hanger is spun around, an inward force called centripetal force acts to keep the penny on the hook, on a circular path, and keeps it moving in a circular motion. The same idea works with a bottle of water. If you swing it with a smooth motion, it won't spill, but just don't try it indoors just in case. This contrasts with centrifugal force, which, if you were the penny, would feel as though you were being pushed away. What you would actually be feeling is the inward centripetal force keeping you from going off on a tangent. Trick 4. A moving ketchup sachet. For this magic trick, you'll need the following items: sachet of ketchup or other condiment, salt, a 2-liter plastic drinks bottle, and safety goggles. Fill a bottle right up to the top with water. Put the ketchup sachet, still sealed, inside the bottle. Seal the bottle up tightly. If the ketchup sinks, add a few spoonfuls of salt to the water. Squeeze the bottle. The ketchup should sink when you squeeze the bottle and float upwards when you release it. Let's look at the science behind this magic. There's a small air bubble inside the ketchup sachet. When you squeeze the bottle hard, you put pressure on the ketchup, which causes the bubble to get smaller. This makes the sachet denser than the water around it, so it sinks. When you stop squeezing, the bubble expands, making the sachet less dense again, and so it floats back up. Trick 5, the vanishing water. For this trick, you'll need the following items: nappies, newspaper, plastic bags, instruction sheets, and safety goggles. Spread the sheets of newspaper out. Cut the nappy in half while holding it inside the plastic bag. Carefully empty the nappy into the bag, being careful not to breathe in the dust. Gently brush the white powder out of the bag over the newspaper. Remove any fluffy cotton. Pour the powder into one of the paper cups. Pour a small amount of water into the paper cup with the powder in it. Tip the cup, and no water should pour out. So how does this work? Nappies contain absorbing gel called sodium polyacrylate. It's able to absorb 200 to 300 times its own mass of water. When you add the salts, this interferes with its ability to hold onto the water, so it releases it all. The gel is even used in nappies for astronauts in case they need the toilet whilst on a spacewalk.